we don't have so much resources, and also other thing, we face frequently the variability, the variation in our data, particularly in hydrologic data, uncertain predictions, etc. Assessment of uncertainty is carried out through different probability methods. They are distribution, fitting to data, probability and quantile estimations, interval estimation of parameters. We have such terminologies through this study. Probability means the chances, the ratio, the percentage of something happening or non-happening. Quantiles, in quantiles we study the data in parts, sometimes middle 50%, sometimes the first 10%, sometimes last 20% of the data we need to study. So we quantify our data. Interval estimation, that is almost the same thing. We study our data in interval and we find the chances of something to happen or not. The other thing is the parameter. Parameter is the basic measures in our study for our data. Among these basic measures, we have the arithmetic mean, sometimes the median, mode, and for the variability, we have to study the standard deviation, mean deviation, coefficient of variation, the range of the data, like that. So these are called the parameters. The commonly used parameters are the mean and the variance. In structural engineering, failure can cause excessive monetary loss and injury or death. So an extremely low rate of failure is assured in design. We also statistics in such cases. Safety measures are determined by considering risk or probability of failure. First of all, we determine the probability. The chances of something happening or non-happening. Different standards of acceptance are developed based on the probability concepts. We have so many probability tools to study. We will discuss some of them. The common probabilistic theories and tools like histogram, estimation of mean, variance, standard deviation, and probability distribution functions are used for all different disciplines in civil engineering. So, first of all, gentlemen, don't worry about this subject. We will start from very basic and initial, you can say, from the initial concepts. So that's why at the moment you don't have any prerequisite, no need to have any uh, prerequisite for this course. We are starting from very basic. So what is statistics? Actually, what we do in this subject initially, collection and organization of data. Then secondly, we analyze this data, and finally we interpret. After that, we make certain decisions or conclusions about the aggregate. What means the aggregate? Aggregate maybe the total population or the people under consideration, maybe the total area under consideration, maybe certain region, maybe certain facilities provided in certain region. So the region or the people or the things or the items under consideration, the totality of that consideration we call as a population. And any part of that population is called a sample. We study the samples because sometimes it is not possible to observe, to study all the parts, all the items, all the members of the population. So through sample, we draw conclusion about the aggregate. So next, the reference books. One is the theory and problems of theory and problems of statistics by Sham's outline series. And we will follow its and secondly for application we will consult this book, Applied Statistics for Civil and Environmental Engineers. Both the books you can download. Both are available online. If you have some problem in downloading, contact me. I will provide you. So first of all, we have two parts of our study. One is descriptive statistics and other is inferential statistics. Descriptive in descriptive statistics, we just described our data. We just describe our information that we collect sometimes through a certain survey, and sometimes we obtain this information through certain experiments. This information is called our initial data, primary data, raw data. So if we describe this data as it is, this is called descriptive statistics. Once again, go through this definition that what is statistics? Collection and organization. First of all, we collect and then we represent it graphically or numerically. Graphically, we express our data in through certain graphs like bar chart, histogram, frequency curve, etc. We can also represent our raw data numerically. We represent our data through certain tables by using certain classes. We represent our data in the form of groups. These groups are actually the classes, and these classes are constructed in certain tables. So in first part, we just represent our data without calculating anything. This is called the description of the data, descriptive statistics. For the analysis purpose, we calculate some measures, some statistical measures for this data. We calculate the parameters of the data. This data may be from the sample or it may be from the population. In both the cases, we have their parameters. The parameters of sample data are called statistic. And the measures about the population are called the parameters. And then on the basis of these, actually our second part becomes the inferential analysis actually. We draw inferences, we draw conclusion, we calculate certain measures and also apply certain techniques on these measures to draw certain conclusion. So this will be the process. But first of all, we should know the basic statistical measures and also the basic statistical techniques. For example, we have 30 observations as a sample data. 30 batteries were tested to determine how long they would last. This is the purpose of our study. We need to study the lifetime of certain batteries. Also, we can study the lifetime of certain mechanical tools. We can also study the lifetime of certain bridges or buildings. So for this purpose, first of all, we collect certain information. So here we have, let's say we have 30 measures. This may be the lifetime from the past experience. This may be their damages. This may be the number of deaths. This may be the number of years under observations. This data may be in seconds, in hours. It depends what we need to study. And also with which units. So in this case, currently we have data of the lifetime of the batteries in minutes. The units considered in this data are in minutes. Okay, we have a numerical data and we need to construct a frequency distribution. Or you can say a frequency distribution table. Further, we will construct a histogram and ogive. All these three things are represented in the following boxes. So how to start to construct a table? You need to make certain classes. Sometimes the restriction is given that you must construct 10 classes or 8 classes. And also sometimes it is mentioned that the width of your classes should be of 5 units or 10 units or 20 units. Sometimes, and as in this example, these restrictions are not imposed, are not given. So we have to do all these things. We have to decide about the number of classes and also we have to decide about the width. We must have the suitable number of classes with suitable width. It depends upon the range of your data. So first of all, check your minimum value and the maximum value. The minimum value in this case, can you trace out? Three 371, 92, 363. I think this one is the smallest value. Okay, in 400s, 428, 428. Is there any other greater than 438, 428? 400, 400. There is one value which is greater than 428. Find out. 431. Here we have. So this is our largest value. The smallest one is 363. Find out the range. How we calculate the range? Range is, in this case, 431. 431 minus 363. 363. So this is the range. 430 minus 363. 68. 68 our range. Now if we decide a class width of 10, so divide this range by 10. We have 6.8. Round off this figure, 6.8 means 7. So 7 number of classes we may have, not exactly, we may have 7 number of classes if we set our class width of 7, class width of 10. Okay. How to construct these classes? As the minimum value is 363, we can start with 363, but for our convenience, we start from 360. 360 to 369. So in this way, we have 10 values in this class. 360, 361, 362, 363, and so on up to 369. We have 10 classes, 10 values in this class. Next one, from 370 to 379. In this way, again, we have 10 number of values in this class. As 379 is considered here, so our next class will start from 380. 382, 389. Next one, 392, 399. So on. Finally, we have 432, 439. All the class width must be the same. But if we start from our first class with the value 363, even then it is true, but it will take some time to construct the rest of the classes. That's why, for our convenience, we have constructed the classes with this manner. In second column, now put these tally marks, the lines for these values. 423, 423 will be in this second last class. So put a mark for 423. Then 369, 369 here in first class. So put a line, vertical line for this value. Next is 387, 387 here we have. So put a line, vertical line, which we call as a tally mark, tally mark. So a vertical line for this value. So one by one, put these marks, tally marks for all these values in our data. So fifth line will be crosswise. As we have 4 vertical lines in this class, 1, 2, 3, 4, and fifth will be across these four lines. Next, sixth line again vertical, 7th, 8th, 9th, and 10th again across the next 4. We do this practice just for our convenience to count these line segments. Just for the convenience to count them. Okay, in this way, we have finally 2 marks against this class. So the frequency for this class is 2. We have 3 marks for this class. So the frequency of this class is 3. And so on. Finally, in the last class interval, we have a frequency of 1. If total frequency is 30, equal to the total number of values given in this data, that's mean this frequency table is perfect. Now we need to construct a histogram. For this purpose, okay, if we construct rectangular bars for this data, for this frequency table, so along x-axis, we will construct these classes First one from 360 to 369. Next one 370 to 379. So in this way we have a gap between these classes because first one is ending at 369, next one starting with 370. There is a gap of 1. Okay, if we construct rectangular bar with the heights according to these frequencies, their corresponding frequencies, so we will have I have not constructed. Okay, we will have such rectangular bars, but with gaps that will be called as a bar chart. Simply a bar chart. But if the classes having no gap, if the classes are adjacent, then it becomes histogram. This is the difference. So you should try both the figures. First, construct bar chart. Bar chart must have gaps between the rectangular bars, and in histogram, all the bars should be adjacent. But data is not allowing us to construct adjacent bars because in our data, the classes have gap. So first of all, fill this gap. Fill this gap. How can we fill this gap? Okay. Let's say we have constructed a frequency distribution with this fashion, with this table. But further, we need to construct a histogram. So for this purpose, we must have the adjacent classes, the classes without any gap. What is given? We are given the classes from 360 to 9. Next one, 370 to 379. Next one, 380 to 389. 90 to 399. 400 to 409, 410 to 419, 420 to 429. Okay, there is a gap of 1. How can we fill this gap? Okay, first of all, we must know the gap. This gap is of length 1 in all the cases. Is it true? This class ending at 369, others next one starting with 370, this one ending at 379, next one starting with 380, and so on. In this way, all the classes have a gap of 1. So subtract half of this difference, subtract half of this difference. This difference is of 1. So their half is 0.5. So subtract 0.5 from all the lower class limits. From all these lower limits, we have 459, 459, 59.5 to and add the half of the difference in all these upper class limits. So add zero point 0.5 to this upper limit. We have 369.5. 369.5. What happens with the next class? The same practice we will do for with all these classes. Subtract 0.5 from each lower limit and add 0.5 to each upper limit. Now in second class we have 369.5, 369.5 to 379.5. Now repeat this thing for all the classes. 379.5, 379.5 to 389, 389.5. Next one, 389, 389.5 to 399.5. Next one, 399.5 to 409, 409.5. Then 409, 409.5 to 419.5. Next one, 19.5 to 429.5. Okay. We have to remember both the styles. This style is called class limits, and this style is called class boundaries. Now construct rectangular bars for these class boundaries. Automatically, we will have a histogram. The height of first rectangular bar is according to the corresponding frequency of 2. Second bar with the height of 3. Third one with the height of 5, and so on. So this is a technique to construct a bar chart and also a histogram. Okay, we before discussing this figure, we have a difficulty in construction of a histogram. Okay, before discussing this difficulty, let we have this data, and we need to construct a histogram and a cumulative frequency histogram. The same practice we will do here. First of all, we need to construct the classes and count the number of values falling in each class by putting tally marks for each value. I mean to say that construct a frequency table for this data, as we have done in our previous example, but with a little change. What is that? Consider here the class boundaries. Because further we have to construct histogram. So why shouldn't we construct the class boundaries initially? What will happen? We have constructed, let's say, these class boundaries, and what will happen? For the tally marks, our first value 119, 119. So put a mark for 119, 125, 125 again in this class, 126 in the same class, 128, 128 is in this class, 128, 132 in the same class. Now consider the second column, 135 three times, 135. Now there is a problem. Now there is a difficulty. What is that difficulty? If we have constructed class boundaries So, and we have a value 135 in our data. So, where should we have to place it? Either in this class or in this class. There is a repetition, 135 here and also 135. Remember, remember, in class boundaries, all the upper class limits, all upper class limits, they are repeated. 127, 127, 135, 135, 143, 143. Remember, all these upper class limits will be considered in their next class interval. So 135 will be here, not here. 135 will be in this class. All the upper class limits are considered in their next class interval. So we have 135 three times, 136 and 138. 138. Okay. 138 in third column, 138, 140, 140 and 142. Again 142. Next column, 144. Obviously in this class, 144, 144, 145. Also in this class, 145 and 146. 146, 146, 147, two times, 148, 149 and 150. 152 times. Yes, two times. 153. 153 will be in this class. 153, 154 also in this class. 156, 157, 158 and 161. Again consider these classes, reconsider. We have 152, 1, 2, 3, 4, 6, 7. 152 in this class, 153 again in this class, 154, 156, 157 and 158. 158. Okay. 161 in this class, 163 also in this class, 164 in this class, 165 and 168. First of all, check whether these classes are perfect. We have set a class width of 8. cumulative frequency along y-axis. So this will be a cumulative frequency histogram. Highlight the midpoints of the top heads of all these rectangular bars. And join them with a smooth freehand curve. This curve is called cumulative frequency curve or the ogive. There is another way to construct an ogive directly without constructing this histogram. Consider the midpoints of all these intervals along x-axis. How to find the midpoints? Midpoints as we have the values in this class from 119 to 126. Add both the endpoints and dividing by 2, we have the midpoint. Midpoint falls between 122 and 123. So the midpoint value is 122.5. 127 is not here. 127 is in its next class interval. Here we have 127, 128, 129, 130, 131, 132, 133, and 134. So midpoint falls between 130 and 131. So the midpoint value is 130.5, and find all others. Now consider these midpoints along x-axis and highlight these midpoints here by considering cumulative frequency along y-axis. I repeat, consider midpoints along x-axis and cumulative frequency along y-axis. Here we have this midpoint whose cumulative frequency is 3. So highlight this point. In the middle of this rectangular bar, here we have our second midpoint whose corresponding cumulative frequency is 5. So highlight this point 5. Third midpoint is here and corresponding cumulative frequency is here. So highlight this point. In this way we have our dots are the points against each midpoint. Join them with a smooth freehand curve. This is called ogive. This is called cumulative frequency curve. The difficulty we have in some cases when the class widths are not the same and we need to construct a histogram. The class width of first class interval is 10, second is 10, third, fourth is also 10, fifth is 20, this one 20, this one 30, and this one class width is 40. We have this situation because we need to construct a histogram, so we must have class boundaries. So convert these class limits, given class limits, to class boundaries. The corresponding class bits are 1 unit, 1 unit, 1 unit, 1 unit. This one double than the previous. This one thrice and this one fourth. Also you can mention here the exact measure 10, 10, 10, 10, 20, 30 and 40. So in such cases, when the class widths are not the same and we need to construct a histogram, we treat the height of these rectangular bars proportionally. How we find the proportional height? Divide each frequency with the corresponding class width. With the corresponding class width. So we have 0.3 and 0.2. Or consider the class widths in units. Now consider the class boundaries along x-axis and the proportional height along y-axis. Remember, when the class intervals are not the same, we consider class boundaries along x-axis and the proportional height along y-axis. This will be the histogram in this case. Next, we will study median, mode, quartiles, deciles, and percentiles. Okay, we have completed only 2 pages. Okay. I will send these pages. Do we have a group uh, on WhatsApp? I think not. I have a group for the other classes. So don't worry, I will send this lecture on a group on WhatsApp today, inshallah. One, two, and make a PDF. I have lost my cursor. Yes. Just a minute. Both the books and this lecture, I will send you, inshallah. Any question? अच्छा, ये एक और बात, हमारे फॉरेनर भी बैठे हुए हैं, कुछ लोकल स्टूडेंट्स भी हैं। कोई भी क्वेश्चन हो तो फौरन पूछ लिया करें, खामोशी से ना बैठा करें। लेक्चर के दौरान मुझे वहीं रोकें और पूछ लें, वरना तो बैठने का फायदा नहीं है कि एक बात आपको समझ नहीं आ रही, आप मेरे साथ चल नहीं रहे, तो फायदा क्या बैठने का। फौरन पूछ लिया करें। Now, secondly, how should be the attendance? Should I call the roll? Just a minute. So I need to call the roll. Today 30, 21. Okay. जी 56 हैं जी 56 56 present.
Yes, sir. 56 present.
58 59
Yes, sir. 59.
60
Yes, sir. 60 present.
61 62 63 4 65.
Yes, sir, 65.
All right. There is some issue with the 67 and 69. Maybe there I जी इस वक्त है ये 67. अच्छा आपका ऐड है मैंने काफी ट्राई किया ये ऐड आपने फिर खुद किया होगा ऑल राइट 67 present, now 68, 69, 70, 71, 72,
Yes, sir. 71 present.
72, 73,
Yes, sir, 72.
72, 73,
70.
73. ये आपको शो
Yes,
भी
sir,
हो रहा है
73.
इसे कंफर्म कर लेना आप कंफर्म कर सकते हैं या आपको अटेंडेंस शो आपके सामने मैं लगा रहा हूँ ठीक है तो इसलिए बाद में नहीं कोई ऐसा ही कि वो मुझे आवाज़ नहीं आई थी या मुझे पता नहीं चला था आपके सामने अटेंडेंस हो रही है What about 73
present.
Okay,
Yes, sir.
74, 74, 75, 76,
Sir, 74 present.
74. All right, 75, 76. अच्छा जी मुझे आवाज़ नहीं आई 76, 77,
Yes, sir, 77.
78 ये सबसे पहले आए हैं जी इन्होंने ज्वाइन किया 78, 79.
Yes, sir. 76.
जी रोल नंबर बताएं
Sir, 76. Yes, sir.
एक रोल नंबर बताएं
Sir, 76 present. Sir. 76.
76,
Yes, sir.
79, 80,
Yes, sir, 80 present.
81, 82, 83,
Yes, sir, 83.
83, 84, 85,
Yes, sir, 85.
86,
Yes, sir, 86 present.
87,
Yes, sir, 87.
Yes, sir. 88.
89,
Yes, sir. 89.
90,
Present, sir. 90.
91, 92, 93,
Present, sir.
94, जी
Sir,
बताएं,
93 present. 93
90
present.
94, 95, 95R, 96,
Yes, sir. 96.
97, 98, 99, 100, 101, 102, 103,
Sir, 103 present. Sir, 103 present.
and 104.
Yes, sir. Present.
1, 2, 3, 4, 5, 6, 7, 8, 9. Twenty-three. हाँ जी, अटेंडेंस 2 की ज़्यादा है, 21 प्रेजेंट है इस वक्त, अटेंडेंस 23 की है। ये भी अच्छी बात नहीं है। मैं इसका प्रिंट ले लूँगा, आज मेरे पास प्रिंट नहीं था, तो फिर यहाँ से जो हाईलाइट ये करेगा उसी की अटेंडेंस होगी। ये थोड़ा सा ना ज़रूरी है कि मैं बल्कि ये भी कोशिश करूँगा कि 2 अटेंडेंस हों आपकी, एक शुरू में और एक बाद में, क्योंकि ये डबल लेक्चर है तो 2 दफ़ा अटेंडेंस होगी। सिर्फ आप अटेंड करते रहें, साथ साथ मेरे चलते रहें, कोई इशू नहीं है। ये सब्जेक्ट आसानी से हो सकता है। अगर आप समझें कि किसी और से पढ़ लेंगे, सीनियर से पूछ लेंगे, तो ये भूल जाएं कि ये सब्जेक्ट भी हो सकता है या नहीं हो सकता। ये नहीं होगा। जो मैं पढ़ा रहा हूँ ये क्वेश्चन चेंज होकर थोड़े थोड़े, देयर विल बी अ लिटिल चेंज फॉर द एग्जामिनेशन पर्पस। तो वहीं पे बस वो रह जाएगा ये मसला। यहाँ समझेंगे, ये पढ़ेंगे, फिर ये आसानी से हो सकता है, अदरवाइज मुश्किल हो जाएगी। एक तो ऑनलाइन का सबसे बड़ा इशू है, दूसरा है कि आपने मुझे सुना भी नहीं है, तो हो सकता है फिर किसी और का पेपर तो दे सकें, मेरा पेपर नहीं दे सकेंगे, ये होगा नहीं, मुश्किल हो जाएगी आपके लिए। किसी और से पढ़ने की ज़रूरत नहीं है, आप मुझे बताएं। एनी टाइम, नाउ यू आर विद मी, you can ask any question during this semester, anytime. Send text. Inshallah, I will reply. Okay, Allah Hafiz.